Today's video will explain the UML class diagram for the list class. Hello, I'm James Helfrich. The standard template library list is built from a linked list. This video will explain the UML class diagram of the overall list design, including all the member variables, as well as all the methods. Okay, whenever we start with a class diagram, we're always going to start with, well, an empty class diagram. In this case, all we have is the list. We know there are going to be attributes. We know there are going to be methods. Now, every container is going to have the same beginning. It's going to have a constructor, a collection of constructors. It's going to have a destructor, especially because the list is going to create and destroy items. It's going to have an assignment operator, a swap, and a clear. Every container is going to have the same thing. Now, the list is also going to have a size and an empty. How are we going to determine how many elements are going to be in the list? The answer is I have an attribute called num_elements, which is an integer. So I have to have that. I'm also going to have a push front, a pop front, and a front. The push front and the front both work with a T, so this is going to be a template class. So I'm going to put the little T in the upper right-hand corner now. Now, how am I going to implement this? Well, I have to have a pointer to the first node. I'm going to call this P head, and that's going to be of type node. And so that means there has to be a node that's going to be associated with it. Now, this node class is going to be a nested class within the list, and I indicate that with a pinwheel. Now, what's the relation between list and list node? Well, there's going to be an association for sure, but now since there's a member variable of type node, then it's going to be at least aggregation. But notice the list class is going to create and destroy all the nodes in the linked list. And since it creates and destroys them, it's going to be composition. Now, notice I have a single pointer here. Therefore, one might expect the numerosity to be 1, but it's actually more than 1 because every single node in the linked list is going to be created and destroyed by the list. Therefore, the numerosity is many. 0 to an unlimited number. There could be 0 when the list is empty, or there could be 100, or it could be 1,000. Now, let's dive into that node a little bit more here. We're going to have a member variable called data of type T. Now, this node is not going to be a template class, even though I have a T, and that's because I get the T from list, because list is a template class. Because I'm a nested class, I get the T from my parent. But now since I reference that T, then I'm going to have an association with T, and I don't know what data type T is. It could be an int, like a built-in type, or it could be another class, whatever, but there is an association. Now notice that I have a member variable of type T, therefore it's at least aggregation, but since this particular node creates and destroys it, it's going to be composition, and there's always going to be exactly 1 is my numerosity. Now I'm going to have another attribute called pNext to the next node in the linked list, as well as a pPrevious. And this is going to be related by aggregation. In other words, if I create and destroy one node, I do not necessarily create and destroy pNext and pPrevious. I just can have a reference to it. And what's my numerosity going to be? It's going to be 0 to 2. 0 in the case that I am the only node in the linked list. 1 in the case that I am the head or the tail node in the linked list. And 2 in the case I'm somewhere in between, which means I have both a pNext and a pPrevious. I'm also going to create 2 constructors for convenience sake. Both of these will set pNext and pPrevious to the null pointer, but the non-default constructor will also set my data as well. Now notice that this is really going to act like a structure. Namely, I'm going to have public access to my pNext, pPrevious, and data, and that's because the list class is going to manipulate all those for me. So there's no real benefit of making it private, but I'm also going to have constructors for the ease and convenience of creating and destroying nodes. Okay, let's go back to the list class here. Let's see here. I need to have a push back, a pop back, and a back, which means I also need to have a ptail, which is the end of the list, which should be a node as well. Now notice, just because I have 2 pointers does not mean I have any more or less nodes than if I had 1. I just need to have a ptail so I can easily and conveniently access the end of the list, which is necessary for pushback, pop back, and back. Now, does a list have any other methods that are important? And the answer is, well, quite a few. I have an erase, I have an insert, I have a begin, and I have an end. Each one of these is going to require an iterator. So I'm going to need to have a list iterator. And this is going to be, of course, a nested class with the list. Now, observe, there is no attribute of type iterator in my list class. Therefore, there is no aggregation, there is no composition. There is an association, and I could put the association arrow if I like, because erase, insert, begin, and end take or return iterators as parameters, but it's not an important detail that I feel the need to add. Now, my iterator has a single member variable called a p node, and this right here is going to refer to a node itself. Now, notice if I create and destroy an iterator, I do not create and destroy the node it points to. Therefore, this is going to be aggregation. And what's the numerosity going to be? 0 to 1. 1 indicates this iterator points to a node, and 0 when I have the end iterator, in other words, the null pointer. You can learn more about the implementation of the list in the implementation section of the list chapter of the C++ data structures textbook.